Hi, it's Dr. Z. In this video, I will introduce the concept of hypothesis testing. By the end of this video, you'll be able to explain the process of hypothesis testing and conduct a hypothesis test using a z-score for a single score x. Please feel free to pause the video at any time to take notes on the chapter handout. Hypothesis is just a fancy word for saying a prediction. Hypothesis testing refers to testing a prediction that we have about a certain idea or a potential new treatment. Since a population is too big to study, we will take a sample and test the sample to see if our prediction worked or not. In other words, hypothesis testing is a statistical procedure to decide whether the results of a study, which used a sample, supports a hypothesis about a population. This diagram illustrates the process of hypothesis testing. Research often starts with the question that we want answered. Step 1, the yellow Lego, involves stating a hypothesis or prediction about the population. These hypothesis statements will use population notation, such as mu and sigma. Step 2, the blue Lego, is where we use the hypothesis to predict the characteristics that the sample should look like if the study worked. In other words, we set the criteria to decide if the study worked or not to make a decision at the end of the study. Step 3, the red Lego, involves selecting a random representative sample, collecting data after we experiment on that sample, and then calculating statistics on that sample. Step 3 involves math and corresponding formulas. Finally, step 4 is to compare the sample data to the prediction made from the hypothesis. In essence, we're comparing the sample back to the population. We will make a decision to determine if the data fits the hypothesis or not. This diagram should resemble a previous diagram on the relationship between populations and samples when conducting research. Test statistic is a technical term that refers to the type of statistical test or procedure that we will conduct on a sample to test a hypothesis. Chapter 4 introduces the first test statistic that you will learn this semester, the z-score statistic. Chapter 3 introduced how to calculate z-scores for a single x-score. We will build on z-scores and now use them for hypothesis testing for a sample of a single x-score. This is the first of many test statistics this semester, and each will follow the same process. So let's jump right in. The process of hypothesis testing started with the yellow Lego. Step 1, state hypotheses. There will be 2 hypotheses. The first is called the null hypothesis. The word null means 0 or nothing. In statistical notation, it is H subscript 0, where H stands for hypothesis and 0 stands for nothing. In other words, we're hypothesizing that there will be no difference between the sample and population. I don't know about you, but predicting that nothing will happen is boring. Therefore, we need a research hypothesis that suggests something will happen. In statistical notation, it is H subscript 1, where the H stands for hypothesis and 1 for the first research hypothesis. Here, we are hypothesizing there will be a difference when we compare the sample to the population. Writing hypothesis statements for the first time can be confusing for students, especially since you need to write them in both a sentence and in statistical notation. For the null hypothesis, recall that we're predicting that nothing will happen. Therefore, in a sentence, the null hypothesis would be written like this. There will be no difference on the dependent variable, between the sample that receives the independent variable and the population who did not. Now, recall back to Chapter 1 that the dependent variable is what is being measured in the study. The independent variable is being manipulated by the researcher. You will need to fill in what the dependent and independent variables are in the hypothesis statement. Please note that the words sample and population are in bold. This is to remind you how important it is that you clearly state that a sample is being compared with the population. Now, you will also need to write the null hypothesis in notation. These hypotheses are about the population, so they will use notation for population mean, which is mu. The prefix TX here is clinical terminology for treatment. In an actual problem, you will replace TX with the name of the treatment or a shortened version of the treatment. This treatment is the independent variable that was given to the sample. If we were to translate this notation into words, it would say, if we could give the entire population the treatment that the sample received and nothing happened, then the treated population is equal to the population mean. When writing in notation, you will write in the numerical value of the population mean into the statement. Now, the research hypothesis will describe that there is a difference between the sample and population. The research hypothesis would look like this in a sentence. Like the null hypothesis, you will need to fill in what the dependent and independent variables are in the hypothesis statement. The research hypothesis also needs to be written in notation. If we were to translate this notation to words, it would say that if we could give the entire population the treatment that the sample received and something happened, then the treatment population is not equal to the value of the population mean. I understand that the concept of writing hypothesis statements may be difficult to understand right now. You're going to practice this every week for the rest of the semester. The lecture example at the end of the video will provide additional clarification. Step 2, the blue Lego, is to set the criteria to make a decision whether the study worked or not. This step builds on what you learned about probability and the normal curve in Chapter 3. Recall that outliers, or extreme scores, on the normal curve are not very common or expected. In fact, outliers that are 2 standard deviations away from the mean occur approximately 4% of the time. So we're going to use probability to help set criteria. First, we will set our significance level, called P. Remember that P stands for probability. We are using probability to define an outlier or an extreme score. Thanks to statisticians, they made it easier on us by telling us that we will use one of 2 significance levels, either a 0.05 significance level or a 0.01 significance level. Reminder that probability can be reported in decimals, fractions, and percentages. So a 0.05 significance level is the same as 5%. Now, statisticians made it even easier and actually told us that 0.05 is the preferred significance level to use. Now that we know our P, we need to find the critical value or critical region that tells us what the sample should look like if the study worked. We will find the corresponding z-score for the selected significance level. In order to do so, we will use the normal curve table and our p-value to find the z-score. Now, the next slide will demonstrate why the critical region for a 0.05 significance level will always be Z equals plus or minus 1.96 two-tailed. So let me explain why that is. Let's graph what the critical region Z would look like. Using a normal distribution, where are our outliers located? Well, outliers are in both tails because it's two-tailed. So we have two critical values, one above the mean and one below the mean. The significance level of 0.05 refers to 5%. Since a normal distribution is a symmetrical distribution, we split the 5% in half, and each tail is 2.5%. Using 2.5% in the tail, we go to the normal curve table, and the normal curve table will give us the answer that the corresponding z-score is a 1.96. In this case, it's a plus 1.96 for above the mean and a minus 1.96 for below the mean. I encourage you to pause the video and look this up yourself in the normal curve table. Step 3, the red Lego, involves collecting data and calculating sample statistics. This step involves calculating the z-score for the sample score X, and we're going to use population for comparison. As such, there is a new z-score formula to calculate. Notice that this looks a lot like the z-score formula from Chapter 3. That's because it is. Since we're comparing the sample X to the population, we're going to replace M, which would have been here, with mu, and SD here with sigma. So we're comparing the sample to the population. The most common mistake in step 3 is to accidentally use the z-score formula from Chapter 3 instead of this modified formula from Chapter 4. Step 4, the green Lego, is to make a decision about whether the study worked or not. Here, we're comparing the sample z-score from step 3 to the population prediction or critical value z from step 2. Based on this comparison, we will make one of two decisions: reject the null hypothesis or fail to reject the null hypothesis. You will watch a second lecture video that explains these two decisions. Well, now that we have reviewed the steps of hypothesis testing, are you ready to practice your new knowledge? I have one lecture example for you to review. In your chapter handout, you have a space to write the steps. This is a summary of the 4 steps that we described earlier in this video. Please note that these steps are for a two-tailed hypothesis test using z-scores. Please pause the video to write down these steps on the chapter handout. The lecture example wants to know if blueberry supplements have an effect on cognitive function. The details of this research study are provided in your chapter handout. This research study is giving blueberry supplements to the sample. So the supplement is the independent variable, which is being manipulated by the researcher. Cognitive function is being measured to determine if the supplements worked. As such, cognitive function is the dependent variable. In this lecture example, we know that the adult population scores a certain mu and a certain sigma on a cognitive test. Since, well, we can't study the entire adult population, we have one patient take blueberry supplements for 6 months. Then we will compare this one patient's score to the population to see if the supplements worked or not. I encourage you to pause the video here and try to do the 4 steps on your own first. Then resume the video to show the answers. Step 1. The null hypothesis is predicting that there will be no difference in cognitive function between the sample that receives the blueberry supplement and the population who does not receive the supplement. The words cognitive function are underlined because it's the dependent variable which is being measured in the study. The words blueberry supplement are also underlined because it is the independent variable, what was manipulated or given to the sample. Since the treatment in the study was blueberry supplements, I shorten it to BBS. In notation, it would be mu BBS equals 80. In other words, if we could treat the entire population with blueberry supplement and nothing happened, then the treated population should equal the population mean. In the lecture example, the population mean was mu equals 80. So we will place the numerical value of 80 in the notation. Now, on the other hand, the research hypothesis will reflect that there is a difference on cognitive function between the sample that receives blueberry supplement and the population who does not. In notation, mu BBS does not equal 80, meaning that if we could treat the entire population with the blueberry supplement and something did happen, then the treated population should not equal the population mean. Step 2. As the researcher, we get to decide the significance level, and the preferred one is 0.05 significance level. Since we don't know if the blueberry supplement is going to increase or decrease cognitive functioning, we need to draw a critical region for both tails, above and below the mean. The corresponding z-scores for a 0.05 significance level is two tails z equals plus or minus 1.96. The box indicates the final answer that I will be looking for on problem sets and exams. Step 3. This step involves calculations. We will use the modified z-score formula that allows us to compare our sample x-score with the population mu and sigma. Using the formula, we will plug in the values for x, mu, and sigma that are given to us in the lecture example. The z-score for the one patient who took the blueberry supplement is z equals plus 3. The box indicates the final answer that I will be looking for on problem sets and exams. Now, I want you to start thinking like a researcher. Anyone can just plug in numbers into a formula and give me a final answer. What I want you to learn is how to read and interpret research. So, what does this z equal plus 3 really mean? Well, the plus sign indicates that it is above the mean, or that there's an increase. Our dependent variable, or the variable that we are measuring, was cognitive function. Putting those two together, the z-score means that blueberry supplements appear to increase cognitive function. This initial interpretation of the z-score value is critical in writing summary and interpretation statements. Step 4. Now, after all that hard work, we need to make a decision to determine whether the study worked or not. In this step, we will compare the sample z-score calculated in step 3 to the population prediction determined in step 2. In other words, does the z equal plus 3 that we just calculated fall into the critical region z from step 2? Using the graph, we can see that the plus 3 that we calculated is past z equals plus 1.96, meaning the answer is yes. It does fall in the critical region. then the decision is to reject the null hypothesis. The box indicates the final answer that we will be looking for on problem sets and exams. Now, still thinking like a researcher, what does it mean to reject the null hypothesis? Well, this decision means that the study appears to be statistically significant. Again, this initial interpretation of the decision is critical in writing summary and interpretation statements. After a hypothesis test is conducted, the researcher must report and interpret the results of the study. You will watch a follow-up lecture video that reviews how to write summary and interpretation statements for this specific lecture example. In the summary, research involves testing hypotheses using a statistical procedure in order to determine the results of a study. Learning how to conduct a hypothesis test is a major Lego building block needed to understand statistics.